Well guys, are you ready for some more mathematics? Let's go and have a look at something else. Okay, this is very, very interesting. Check this out. A sequence is really 2, 5, 8, 11, 14, and 17. You've got little semicolons there. They're separated. You're not really doing anything with them. 2, 5, 8. What are we doing? We're putting them there. We can use our B plus C, or our A plus N minus 1D to generate a whole lot of terms. But now, we call that a sequence, but now a series, we're doing something with the terms. That's called a series. We're actually adding or subtracting. Now look at this. 2 plus 5 plus 3. It's still the same as the top one, but now we're actually summing. If I said to you, what is the sum of the first two terms? What's 2 plus 5? Is 7. You're adding up the first two terms. We're talking about summing. Okay, this is interesting. You're not just interested in the third term. You are interested in now adding. Okay, here's some more formulas coming up. Okay, now check this. 2, what is the sum of the first three terms? Have a look here. 2 plus 5 is 7, plus 8 is 15. Okay, so hold on to this. We now want to know what are the sum of a whole number of terms. Okay, so you could work out the sum of the first 6 terms, but now it's easy to do that manually. But what if we have to work out the sum of the first 1,000 terms? We need some formulas to help us. Now, have a look here. Let's take the one where it's linear or arithmetic. Here's a formula to help us do that. Okay, have a look at this and you'll see how it works now. The sum of the first n over 2 terms, in terms is n over 2. 2a, a is the first term. N is your specific number of terms that you're adding. Could be 3 or 4 or 5, whatever, or 100. And d is your constant difference. By the way, there's another one if you have the last term. Don't panic with that one. You don't really even need that one. If you know the first one, it's fine. And L is the last term. Sometimes you'll go and it ends, the little series ends. Okay. Now, don't panic with that. Let's have a look at an example. Now, we've got a little linear pattern. Look at this. 2 plus 4 gives you 6, plus 4 gives you 10, plus 4 gives you 14. But now they're not interested in the 4th term or the 10th term. They want to know what is the sum of the first 3 terms. You want to add up the first 3 terms. And what is the sum of the first 100? Okay. Look, the adding of the first 3 terms is a joke. But when you go to 100 terms, we're going to need that formula. Okay, now don't panic. Let's have a look at this. Well, what is the sum of the first 3 terms? Well, 2 plus 6 is 8. 8 plus 10 is 18. Now have a look at that. That's pretty straightforward. But now let's use the formula to see if it works. Okay, check this. 18. Hold on to 18. The sum of the a is 2. That's the first term. Your constant difference. Remember, you were adding 4 all the time. And we want to add up 3 terms, the sum of the first 3. So the n is 3. 3 over 2, the n is 3. 2 times the a plus n minus 1, the 3 minus 1 times the d. Okay, so if you work this mess out, what's that? 4. Okay, that's 4 times 4 is 16, plus 4 is 20. Okay, yeah, is that right? Yeah, let's just check it. 4 2s are 8, plus 4 is 12, sorry. And then you work out 3 over 2 times that, and you get 18. That's a simple calculation. And you've got yourself 18, exactly as predicted. If you add up 3 terms, you get it. But now, why this formula? Why couldn't we have just simply added the first 3 terms? True, you could have. But when it gets to the sum of the first 100, we're not going to just pray about this. We're going to use the formula which is sent to you right from heaven. Thank the Lord for this one. Here we go. Now watch this. The sum of the first 100. A is 2, the first term, the constant difference we know. So the sum of the first 100 terms, well, let's see. N is 100 divided by 2. 2a, a fits into there. 100 is the n minus 1 times d, the constant difference. Now, if you just plug this into a calculator, really 100 over 2 is 50, that's 4, 99 times 4. You can really just simply use a calculator. Don't try and do it manually. Use a calculator, and guess what our answer comes to? 20,000. Have a look at that, 20,000. So what did we do? We've looked at linear, where you look at specific terms using b plus c, or a plus n minus 1d. Or, of course, you had the quadratic, where we used 2a, 3a plus b plus c. Now we are adding. Oh yeah, you also looked at the exponential, the geometric one, where it's ar to the n minus 1, where you keep multiplying. But in a case like this, we can now think of summing, adding up a whole lot of terms using this formula. Okay, let's carry on. What about the geometric? This is the one where you keep multiplying. Okay, now remember, geometric is where you multiply by a constant number. 2 times 3 is 6. 6 times 3 is 18. Now have a look at this. This one is going to be the formula that we use. They give you this in the formula for a geometric. R can't be 1, never. You can never just keep multiplying by 1 because that's going to be a problem there. Just bear that in mind. Okay, now have a look at this one. 2 plus 6 plus 18. We've got to add the first 3 terms. Well, what is the sum of the first 3 terms? Well, if you think about it, 18 plus 2 is 20 plus 6 is 26. That's easy. But what about the sum of the first 100? We need a formula. But what is this? 2 times 3 is 6, times 3 is 18, 18 times 3 is 54. So the first term is 2, and the constant ratio is 3. But what is the sum of the first 3 terms? That's easy. But let's use a formula to see if we get 26. Okay, well, what is the A? A is 2, R is equal to 3, and the sum of the first 3 terms, let's put into A, R to the 3 is the n minus 1. These cancel, and 3 cubed is 27 minus 1. Guess what? 26. Now, let's do it for the 100 terms. If we go, A is 2, and there we go. In we go. Plug in the 2, the 3, 100, and you can leave it like that, and you've got the sum of the first 100 terms. Well, people, stay with us. Let's pursue some more mathematics on Matrix Uploaded.